In section 3, we're adding shortcut number 3 and shortcut number 4 on how to tell if two triangles are congruent to each other. These two additional methods are the minimum amounts of information you need to say that the two triangles are congruent. The two that we are going to use next are angle side angle and angle angle side. Angle side angle has the side included between the two angles. Angle side angle. An angle touching a side touching an angle. I know that these angles are congruent to each other because it has a congruent arc which is congruent to the other arc, and a double congruent arc that is congruent to the other double congruent arc, and a congruent mark and a congruent mark. Angle side angle, angle side angle, they match. They're congruent by angle side angle. The side is included between the two angles. You could also use angle angle side where the side is not included. It's the non-included side. An angle cannot touch another angle. Angle, then another angle touching the side. Angle, angle, side. I usually do not read a triangle going this way because the angle would be skipping an angle or this side. You never skip an angle and a side when you're reading a triangle. That's why you go in consecutive order. Angle, angle, side is the only postulate we use where things are not touching each other. Like side, angle, side is a side touching an angle touching a side. Angle, side, angle is an angle touching a side touching an angle. Side, 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 they're all touching each other. The only one that doesn't touch is angle, angle, side, because two angles can't touch each other in a triangle. They just have to be next to each other. Think of it like two angles next to each other touching a third side that is the same. With that being said, everything else I have for you are examples from your book. And so we'll jump to number 7 of your book. Let me look and see. This is 3.3. I want to say it's going to be page 144. We're doing number 7 through 15 and number 20. I'm almost positive that that is correct. And so here's what it says. Determine whether the triangles must be congruent. You're either going to say yes or no. If so, name the postulate theorem that justifies your answer. If not, explain. So you look at number 7. You have a single congruent arc. That's an angle. Congruent to a single congruent arc. That's another angle. That's an angle is the same. We have a double arc and a double arc. And a lot of times they'll make the double arcs offset from each other. Like when I look at this picture, this one's a little bit wider because they don't want you to think that it's one continuous mark. They'll just do them a little offset. But double means it's the same as the other double. So when you look at this, you have an angle and an angle that's the same in both of these triangles. You can't add anything else unless it's one of those things we wrote about in 3.2. Do you see something that you can add here? Something that is congruent to itself, maybe? Is there a shared side in both of these triangles? What letters are shared in both of these triangles? What side length? Go ahead and say the two letters out loud. Segment what? MO is the same as segment MO. It's the same in both. Since this is the first side that is the same as each other, that is marked, I will usually use the single one mark. If it's the second side, I usually use double congruent marks. If it's the third piece of information, I'll add the 3 congruent marks. But since this is the first side that's the same, I usually use the 1. And so now I can answer this question. Are the two triangles, must these be congruent? My answer is yes, they must. If so, name the postulate or theorem that justifies your answer. What would you say? What theorem or postulate would you use? I agree with those of you who said it out loud. That's how simple it is. The only way it gets harder is they start using some things that you learned in Advanced Math 8 or in Math 1. And so some of you may have forgotten some of these things, so I need to point them out to you. That's why I chose number 8. Number 8 has an angle, and it has a shared side. We've used that already. What is shared? What letters are shared? What segment is shared in both triangles? Yeah. So it's my first side. I'm going to put a congruent mark like that. And then they don't give you anything else. And right now you have an angle and you have a side. This is not a side that's congruent to another side. This means something different. This means that it is, do you remember? Parallel. These are parallel symbols. That does not mean congruent. It means parallel. If TR is parallel to US, it doesn't tell you anything's congruent, but what it does allow you is it's supposed to be something that triggers something from your memory where we learned parallel lines and something called a transversal. We learned what's congruent to each other way back in Math 1 or Advanced Math 8, depending where you came from. You learned something like the acute angles are going to be the same. The acute angles are going to be the same. The obtuse angles are going to be congruent to each other. And everything else is supplementary, something along those lines. These angles had names to them. You called them corresponding. You called them alternate interior, alternate exterior. And those all had names to them because when you get to the geometry portion and these are parallel, TS is a transversal. It's connecting the two parallel lines. If this is parallel to this and that's a transversal, then it's the exact same thing. Let me highlight it in blue as this Z shape, what you learned in Advanced Math 8. These two angles that are right here inside the Z or inside the N are congruent to each other because they're called alternate interior angles. And in this problem, I see the alternate interior angles. I have parallel, parallel, here's the Z. This angle here, angle RTS, is congruent to angle TSU. They are congruent to each other by the alternate interior angles theorem that you learned about last year. You probably have forgotten it. So now I'm reminding you about it because you may have to use that. It's the only time you can add congruent angles congruent to each other. Oh, wait a second. Because this is a single arc and that's already been used and I use a single arc, that's generally not what we do. We generally put a double arc and a double arc if it's the second angle that is being used. Double arc, double arc. That makes more sense to me now that I look at this. Now let's answer the question that was up here above number 7. Are the triangles, must they be congruent? Which postular theorem justifies the answer? AAS is the correct answer. The last example that I have for you is number 10. And number 10 says, in triangle, nom, nom, nom. Just sorry, I'm sorry. You guys still say that? No? You guys ever see a cartoon that eats something and it says nom, 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 like that? No? You've never seen anything like that? Yeah. I must be too old. I remember Pac-Man used to go around and eat nom, 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 nom. I mean, that was a thing. You guys are too young for Pac-Man, huh? Have you? How many of you have ever played Pac-Man? Raise your hand. Oh, okay. Oh, I'm pleasantly surprised. Okay. I'm not as old as I think sometimes. Pac-Man's universal. I love it. All right. In triangle NOM, NO is included between which angles? If you need a picture, draw the picture. If not, you can answer the question. I'm going to draw the picture because I am thoroughly explain, hopefully. I may overly explain sometimes, but that's okay. NO is this side. It's included between which angles? Which angles are on both sides of these things? Use the angle symbol. And just so you know, angle O can be written as angle O, or it can be written as angle NOM because that it goes side, vertex, side. Either one is correct. The shortest way to write it is angle O because that's the only angle you can make with it. You can use the shortcut this time. Otherwise, you may have to use all three letters if there are multiple ways to write it. For example, you would never say angle T on number 8. You would say angle RTS because you don't know if we're talking about this angle T or that angle T or the big angle T. Use three letters when there's multiple angles there. Use a single letter if it's the only angle you can do. Angle O and angle N. You can use the shortcut. If there was multiple possibilities there, you would have to write it like this, angle ONM as the side, vertex, side, just so you know. I say that just because geometry is a language. We have to know how to write things for it to be correct. We'll stop your notes right there.